Why do serverless functions cause latency for time-sensitive applications? Imagine trying to catch a train that sometimes arrives on time and sometimes takes a little longer. That's similar to how serverless functions behave when used in applications that need quick responses. When you use serverless functions for deployment and scalability on cloud hosting platforms, a few things can slow things down, especially if your app needs to respond in milliseconds. First, there's something called cold start. When a serverless function hasn't been used for a while, the cloud platform has to set up everything from scratch. It has to allocate resources, load the runtime environment, and get the code ready to run. This setup can take anywhere from a few hundred milliseconds to several seconds, depending on the programming language. For example, Java or Net functions tend to take longer to start than Python or Node.js. If your application needs to respond instantly, these delays can be a real problem. Next, resource constraints come into play. Cloud platforms limit how much memory and CPU a serverless function can use. If your task is heavy, like processing large datasets or doing complex calculations, it might hit these limits. When that happens, the function can slow down or even time out. During busy times, multiple functions might try to access shared resources like databases or external APIs, creating bottlenecks. This competition for resources can add extra delay to your responses. Then there's network latency. Serverless functions often depend on other services such as databases, APIs, or storage systems. These services might be in different geographic regions or networks. Every time your function makes a call to these services, it adds a delay. If your function has to make several calls or retries due to failures or throttling, the total response time can increase significantly. For example, accessing a database in another country can add tens or hundreds of milliseconds to your response time. To make things clearer, serverless functions are usually small, stateless units triggered by events or API calls. They are not always running, which is why cold starts happen. Developers can try to reduce latency by choosing faster runtime environments like Python instead of Java, keeping the function package small, or pre-warming functions by calling them periodically. Placing functions and data in the same region helps cut down on network delays. Using caching or connection pooling can also help speed things up by reducing external call times. While serverless makes deployment easier and can automatically handle high traffic, it's not always perfect for applications that need ultra-low latency. For critical tasks like payment processing or real-time data feeds, the unpredictable delays caused by cold starts, resource limits, and network latency can affect user experience and service-level agreements. In short, serverless functions cause latency because they are not always running, need to initialize on demand, have limited resources, and relying on distributed services. These factors make them less ideal for applications that requiring consistent, very fast responses without extra tuning.